My name is Adam. I'm an Android engineer at TravelPerk. We're a business travel company. And I'm going to talk about our release process and how we manage it these days. So I'll just walk you through what we're going to talk about real quick. Our release process and the CLI app that we're going to talk about in this talk, like what does it do, how we made it, and how we build and distribute it, and how we consume it on Android and iOS as well. Well, actually, we're only going to talk about Android here. And how everything is tied together and how everything is automated. All right. So our release process is split into 4 stages. First one we call preparation. The first thing we do is increment version numbers and across both apps. We update database entries. We have a database that we used to store a lot of data about our releases, like when they happened, who captained the release, if it had any bugs, among other things. And we notify stakeholders. We notify stakeholders in different ways based on the stage that we're at. So sometimes we'll send public messages on Slack. Sometimes we'll DM people privately. It depends on where we are in the release process. A day or 2 later, we go to QA. This is where we cut our release branch, we pull the latest strings and change logs, and we start creating and distributing these internal release builds to our testers, so they can do their QA. We update database entries and we notify stakeholders. That goes on for a couple days. So our entire process, I think, takes about 5 days until we get a finalized rollout. We start our rollout. It's staggered, so it goes in different increments for us. We update database entries, and we notify stakeholders. After that, we do sort of a post-release cleanup. So the way that we create our releases is we cut a release branch from main at a certain point after a code freeze. We release from that, and once it's released, we merge it back into main. If there are any changes, just to make sure that they're back onto main. We create release tags, so that every release is tagged, so we can go back to it if we want to. We generate internal release notes, so when you go on GitHub, you'll find a list of our releases, and there's a diff between the commits, and it tells you what was merged into that release. We update database entries, and we notify stakeholders. Users receive our updates. Good times. It's great. That's the talk. But no, hot fixes exist. So sometimes things go wrong, and you need to create a hot fix for a release that's already live, or it's already live. The way our hotfixes work is, so this is a snapshot of our database, and you'll notice down there's 2 buttons, create hotfix and close hotfix. And when you want to create a hotfix, you click the button, and it kind of does the same steps, but in a much quicker manner. And then there are extra decision trees that's thrown in there for good measure. So sometimes the release branch exists, and you want to create your hotfix from that release branch, but sometimes it doesn't exist, so you want to create it from the tag. And we need to figure that out every single time. And so it's just another step that you do. And once that branch is created, we create a PR automatically for you, and you merge your changes into it. You click the close hotfix button, and we start releasing from that PR. Yes, I hope you sense the theme. There's a lot of work that we do here, and it's repetitive, and you have to remember it. This is a very shortened version of what we do. It's so much stuff to remember, so we wanted to automate it. And initially, of course, we used Fastlane because I assume a lot of you have heard of Fastlane. It's great at what it does. Their tagline is app automation done right, and it is. Fastlane is a great tool, but it didn't really work for us. We used it for a year or 2, I think, and just problems kept piling up for us. So our biggest problem is it's written in Ruby, and we have a lot of custom logic. This database is on Notion. The Notion API is kind of really difficult, and when you want to interact with it in Ruby, it's not easy because nobody, like in my team at least, nobody writes Ruby. We couldn't iterate because, again, like it was kind of a brittle system that was barely glued together, and every time we made a change, it would break something somewhere because we didn't have any tests for that system because we just didn't know how to write Ruby. And it also performed a lot of our build logic operations outside of our code base. So like within the Ruby code, you'd invoke Gradle and it would build your app. And sometimes we have steps that should happen in sequence. And you can't really model that outside of Gradle when it's a Gradle thing. So you have to do it in Ruby. And like you have to wait for a Gradle task to finish and give you a result in Ruby and then check that result and then do the other task that you want to do afterwards. And it's just like so much logic that was outside of Gradle, and it was hard to reason about because especially this like sequential manner of it. And yeah, replicating the same Ruby environment across different hosts was kind of difficult as well. Well, sometimes, like I remember one time someone made a change to how we, I think, truncate strings or something, and it worked on their machine. They pushed it, and it was fine because we don't have tests. And then like a week later, we were releasing, and the release just like wouldn't work. And it turned out this person was using a newer version of Ruby on their machine than the one that we use on the CI. And the one on the CI didn't have the function that they used. So we had to roll back to an older version. But Ruby, like stack traces are worse than Gradles. They're horrible. They're just really hard to figure out. So that also, like every time something like this happens, it just takes a lot of time. One time, we do a lot of Git operations, used to do them in Ruby, and yeah, if you change anything in those as well, they run fine. Like they run fine on your machine, but for whatever reason, in a different state, it breaks on the CI, and it takes you 2 hours to find out why. So initially, there's a project called Fastlane Swift that we wanted to explore because we were like, okay, like Swift is fine. We can write Swift code. We can probably write tests for it. But it's kind of the same. It's just an abstraction layer on top of the regular Ruby stuff. And a lot of the first party, not even the third party, a lot of the first party lanes don't even work with it. So it was kind of useless for us. So yeah, we just like weren't able to iterate. We had this initial version that did some things, it automated some things, some parts of our release process, but like not everything we wanted. And we weren't able to make any changes to it because we were kind of terrified. So at some point, we built Kronos. Kronos is like the code name of our internal tool. This is a press release that we did internally. I don't think you can read any of this, I'm sorry. So Kronos is written entirely in Kotlin. It's a Kotlin JVM app. It's architected in a way that like every Android developer is familiar with. And we distribute it as a CLI app internally to both our Android and iOS repos. It's fully tested / testable. Like the code was written from the ground up to be as open to testing. And it allowed us to iterate. That was the biggest thing that we wanted to do. But I've mentioned iteration a couple times. Like, what does that even do? Like, what do I mean? What did we do exactly? So the first thing we did is we wrote unit tests and integration tests for code paths that we knew were brittle. Everything that Kronos does is backed by tests. For example, I mentioned Git operations. We spin up a fake file system in our tests, and we perform all these Git operations that Kronos does. We perform them on that fake file system to make sure that they work as expected. Those run on every change, like regular testing. It's just much more robust now. And now our release process is backed by actual state that we can use to figure out where we are in the process and how to move forward from there. It automatically generates these internal release notes. So we used to do this manually, and of course you'd forget sometimes, and your PM would come and ask you what was changed in this release, and like it's 1 week later, and you have to do this manually. We don't do that anymore. Kronos just does it for us. And I think this is the best part. Android releases are entirely automated. So this is a screenshot from the docs of a Gradle plugin called Gradle Play Publisher, I think, GPP. And Kronos hooks into GPP, and I'll talk about this later. Kronos hooks into GPP, and it orchestrates our entire release process. So like everything for us requires no human intervention at all. All right. And we're going to talk about how to make the CLI app. So that's easy, right? We just use this library called clicked. You can parse the arguments that you pass into a JVM app yourself, but we found this tool that does it for you, and it makes it really nice to write commands this way. So for us, commands are written just as regular classes, and then the command name is kind of extracted from the class name. So class pull strings would give you a command on your CLI called pull-strings, and you'll notice, it takes arguments. So for example, it asks you which platform you wanna do this for, and you'll notice there's a lot of repositories here because it's just code that every Android developer is familiar with. It's JVM code. It hits different APIs. It does everything that you want to do, but in a way that you kind of find it. Everyone on the team finds it much more reasonable now. So in your main function of the app, this is how clicked works. You kind of just create the CLI instance and you give it a list of your subcommands. So these are the commands that you want your CLI to run. These are the commands that would be exposed in your CLI. This is a small list of what we expose. There's so much more. And this is a screenshot of me just calling the -- help task on our binary. And it shows you a list of the commands that you can perform on it now. So like now we have a CLI dependency on a Kotlin app. All right, and now we're going to talk about how we build and distribute Kronos. So we kind of started with what we want, and ideally this is what we wanted. We want it to be, if you're on the Android project, you go and you do, I don't know, Kronos start release or Kronos do whatever. So we wanted a list of these tasks that would do these things for us, and we wanted to ideally be able to invoke them from the CI or from your machine, wherever you wanted, and we worked backwards from there. So just a reminder, Kronos is just a JVM library. This is what our build script looks like. There's more, but this is just kind of the core of it. It implements libraries that you know, that you're familiar with. It does things that, if you were to read this code, it's just code that you've written before. We set our main class. This is where this is kind of the entry point for your JVM app. This is the one thing that you wouldn't see in an Android project, probably the application block down there. And then, now we can build it, and I wanted to distribute it, and I was wondering how we can do that. And I think, ideally the first question you ask yourself is, can Gradle help me do that? And one thing you can do is if you go into any project, and you can call the tasks task, and it just gives you a list of available tasks on your project. So you'll notice here, there's tasks that assemble it, there's tasks that distribute your project, and the keen-eyed amongst you might have seen that we had applied the shadow plugin earlier, and it's a plugin that creates Uber jars. It just so if you have an app like Kronos that has a bunch of libraries and you want to distribute them as one jar, the shadow plugin does that for you. So we use that to create one binary that we can distribute to teams. As for publishing, again, Gradle makes it really easy. There's a Maven publish plugin. For us, we published an internal artifactory on GitHub. So this is just a sample. You basically just give it the URL of your repo, and you give it credentials that it can use to access it. And you call one function, and it just one task, and it uploads a binary to this artifactory. And yeah, that's it. Like again, you can call tasks on any project that you're on, and it would give you a list of tasks. And usually, if the task author is a decent person, they'd group them. And these are, you can see there's a group of publishing tasks. And the one that we're interested in is the one that publishes to GitHub. So we're going to use that to publish versions. But of course, like now comes the question of how do we manage publishing versions for Kronos? Because I don't know, you don't want everyone to create a branch on their machine and just like upload a new version. So we also automated this. We have this GitHub action, and it kind of monitors when you create a release on GitHub. So on our Kronos repository, when you create a GitHub release, this just listens in, and it calls that publish function and creates a binary from that release and uploads it. Yeah, this is what I'm talking about, these kinds of releases. And ideally, yeah, you want like a change log for every version. All right, so now we have a CLI. We've built it, we've distributed the CLI. You can download it manually from GitHub now, but obviously like you don't want that. So I wanted to use it on Android. I wanted to invoke this CLI from our Android project. So like a normal person, I went to ChatGPT and I asked it what to do. And it gave me this. And it's kind of right, but it's really, really wrong. You shouldn't do this. And I think this is a problem with ChatGPT and like all these AI tools right now. Gradle, a lot of the Gradle code on Stack Overflow and on the internet in general is really, really outdated. It's not necessarily wrong. Like this would do what we want. It's just really outdated, and you don't want to do that today. But it's a good start. So we took it and we started building things, the modern, better way. So the first thing you want to do is you want to create a task that would invoke commands on your CLI. This is our task. As part of our inputs, we take a class path. This is what the task will use to find your main class on your executable. It takes a bunch of arguments. So these are the commands that you pass into the CLI. Takes a working directory and an output file. You want an output file for your tasks, even like not every command on Kronos produces outputs that we can use, but you kind of want an output file if you want your tasks to be cached. And you also need that add cacheable task annotation up there. The reason for this is Gradle checks both your inputs and outputs, and if they haven't changed, it determines that your task is up to date and it doesn't need to be rerun. But if it doesn't have an output, kind of just assumes it's not cacheable. One thing you might have seen there is this Kronos worker class down there in the task action. And this is the implementation of that. It just takes this object from this object from Gradle called exec operations, and you can use it to perform like executable operations. This is kind of very similar to what ChatGPT gave us here when it said you create a task of type Java exec. This is here, except this is how you do it now. You ask Gradle for an exec operations object, and you use it to execute whatever you want to execute. So into that Java exec block, we pass it the parameters that you passed into the Kronos task. We give it the main class that it can find on the class path that we passed afterwards. And then we take that output and store it into our output file. All right, so now we've got this task that executes things on Kronos, but where does it find Kronos? Kronos, like any other library, you want to add it to your class path so it can find it. And I wanted to add Kronos to our dependencies, but I didn't want to add it as an implementation dependency. I want it to kind of live on its own. I want it to live in a configuration away from everywhere else. And a configuration is, when you add a dependency to your Android project and you type in implementation library, something, 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 or test implementation or whatever. These are all called configurations. And a configuration is just a file collection stored on your system. It's just a collection of artifacts and dependencies that your project needs. So there's an implementation configuration that's created by the, I think, Java plugin. And that's what we usually use. But I wanted to create Kronos in a separate configuration. And you can do that yourself. You can do it pretty easily. You just call configurations.create, and you set some attributes about it onto it, like is it consumable, is it visible to others, and then it's created for you. Just add your dependency onto it, and now you have a configuration called Kronos that has Kronos, your library, and then you can feed that to your task, and your task can find Kronos inside it. And it worked until about 2 days later when this happened. We noticed that this configuration that I created, it is still a mystery to me why this happened, but this configuration that we created added about a minute to our sync times, and I don't know why. But afterwards, I found out about detached configurations. They're kind of the same, they're a configuration. The only difference is that they live separately from your main project's configuration. They work in an entirely separate, I don't know if they work in a separate process, but they live separately from your main project configuration, so they don't affect your sync times and stuff. So that fixed that problem. We now have a detached configuration where Kronos lives. We add it to our project, and we register our task. This is what registering the task looks like in Gradle. Task.register. You receive arguments that we receive the args that you pass into the task, and we set a whole bunch of things onto the task as task inputs. So the class path where it can find the, I keep saying this, but the class path is where it can find the executable. So that's the configuration that we just created. The working directory is our root project, and the output file where we wanted to spit out that output to store it so it can be cacheable. We just store it in our build directory. And that's it, profit. We got to this point where we can call, so we add Kronos to our app module, and it's kind of not exactly what we wanted. If you remember a few slides ago, we wanted to say something like Kronos prepare release, and we realized that would kind of require us to create separate tasks for everything that we wanted to do with Kronos. And instead, we opted for a different approach where we just pass, sorry. So we just created one task, and we pass the command as an argument. So instead of being like Kronos pull strings, we say Kronos, this is the argument that what we want you to do, and it is to pull strings or prepare release or start hotfix or whatever. And wow, we're running through these slides really quickly. Automating everything. So now we have this library. It does all of these things for us. Like it talks to our database, it talks to our strings provider, it talks to our CI. It just does everything we want it to do. And we've implemented it into our app as a dependency, but we want to automate everything. That's what I said initially, is like our entire release process is free of human intervention. And the way we do this is we use a tool called Zapier, and we have a bunch of calendar events internally. So we have this calendar event. It's called release train start, for example. Zapier listens in to these calendar events, and as soon as they're triggered, Zapier speaks to Circle CI, and Circle CI invokes Kronos onto our project, and Kronos does whatever we want it to do. So like when this happens, when this calendar event happens, the CI spins up an instance and calls Kronos prepare release or start release or whatever. And we have a whole bunch of these for every step that we want. So for example, we know that on Monday, for example, we want to release to 10% of our users. So we have a calendar event that does the same thing. As soon as that calendar event is triggered, it spins up like a Circle CI, a CI instance is spun up, and it tells Kronos to tell GPP to release the app to 10%. Okay, that's that sequence. I'll just pause here because I kind of ran through that sequence pretty quickly. All right. That was pretty quick. I didn't expect that, but you know, thank you. I guess we have a lot of time for questions. Yeah. Oh yeah, the one thing to add is we're hiring. You can scan this if you want to work with me. But yeah, time for questions. Yes?
What about iOS? I mean, you said you were not going to talk about it, but
Yeah.
you said integration is gradually good, but you do the same.
Yeah, so iOS doesn't do anything differently. So we created this library. We publish it on our internal Artifactory, and iOS, they have their own kind of build system, and they use it to download it as well. I don't know how they do it, to be honest, but it's the same thing at its core. Yes?
I had a question just about for like putting on the CI server to like output the iOS file without having MacBook, specifically for the Kotlin multi-platform.
I don't understand the question. What do you mean?
So for the Kotlin multi-platform, would it be possible to create something similar like CI process where it outputs the executable file?
Absolutely, yeah. We can make this Kotlin native. We just didn't need to. Like, we can make it a native executable that runs on like any platform that you want it to run on. We just didn't.
Without needing to have the Apple computer.
Yeah, I mean, right now, to be fair, right now we run our. Do we run our iOS stuff? I think we run our iOS release process on Linux actually, so because it's separate from building the app itself.
Oh.
Yeah, or at least we kind of orchestrate it in such a way. Like we'll do as much as possible on Linux, and when we need to build, we'll do that on like expensive Mac machines on the CI. Yes?
If something goes wrong during the release process for whatever reason, what do? You just postpone or cancel the calendar event?
Yeah, so that's what we do actually. We can move the calendar events around. Like if we don't want to release on Monday, and we just remove the calendar event. Yes? Yeah. Yes?
For the calendar events, I'm assuming you're doing some sort of parsing on the event data to know what to do. How do you make sure that people don't mess up and do the wrong step in the wrong time?
No one has access to it. Yeah, so each calendar event is tied to a specific key that the orchestrator uses, and not a lot of people have access to that. Like only the people that work on it have access to it. Any yes?
How customizable is it? So basically, if I was going to use this, I would have to use your old process, or could I integrate it on my, if I had using Git flow, for example, the branches, events, how easy would be to try to customize it?
Yeah, so this is not open source, but I think the whole point is I wanted to like show you how easy it is. Like you can build it yourself if you want to. Like I keep saying, it's just a Kotlin app. Yes, that's the beautiful thing. It took like a couple weeks, mostly because we had a massive baseline. Like we knew exactly what we wanted to do because it was written in Ruby, and for the first 2 weeks we were just kind of rewriting that code in Kotlin. But after that, we started making like iterations that we wanted to do, and that's been an ongoing process. Like this has been live for a few months for us, and we've been making changes since then. Like there's a lot of versions that were released internally, but right now it is incredibly easy for us to make changes. To be honest. Any other questions? All right. Thank you very much.